today I will introduce a software accelerator to accelerate the file access in VM and containers. Let's continue the topic for the previous Virtio-fs. So my name is Changpeng Liu, and I'm a software engineer from Intel. And I've been focused on the open source project storage performance develop kit, such as SPDK in the past 5 years. So let's start. Here's today's agenda. First, I will give an introduction to SPDK Vhost-fs. So Stefan mentioned that there is a Virtiofsd to process the host to process the I/O request from the guest in the host side. Similar with Virtiofsd, here we name it Vhost-fs. So it's a different naming. And second, I will introduce the Virtio-fs with the Kata containers and some limitations with SPDK Vhost-fs target. And finally, I will give some future plans about the Virtio-fs. So the motivation, actually at first we are not seeking for a new Virtio protocol. Actually, we are at first we are seeing the Virtio 9P as the first choice, and after we are doing some investigation, we found that the community has started the Virtio-fs, so we changed our mind to switch to the Virtio-fs. Firstly, for this application, we have use-based MME driver in the SPDK project. And on top of our MME project driver, we have a Blobfs store. Actually, it is a block allocator. And on top of the Blobfs store, we have an abstraction layer. We call it Blobfs. Actually, it is only suited for the RocksDB in V. So the requirement is there. So if we want to run some applications such as MySQL or RocksDB in the VM, we can pass it block device into the VM, and then we can format this block device with local ext4 or XFS file system. And what if we can present a file semantics into the VM? So that's the first of the motivation. So currently there are two protocols about the file system in the host. The first one is 9P and the other one is Virtio-fs. So I will skip this part because this is very common. So this is the existing optional solutions using file APIs in one VM. The right part is the block device. We can present a block device into the VM via the vhost user block driver in the QEMU. Actually, for the right part, actually, we can have very big performance numbers, as Felipe mentioned yesterday. So we can get a very high performance number running the web file in the VM. But for most of our users, they may do not need a block device in the VM. They will format it to the ext4 or XFS finally for their real usage. And the left one is the 9P. So look at the two pictures. What's the difference between the, for the most important difference between the two pictures? We can see for the ext4 file system, the guest has the ext4 file system in the guest from the right part, and in the left diagram we can see maybe the logic moved from the guest to the host side. Actually, for the most of cases, they play the same role. introduction to the fields, I think file system in USpace is an interface for USpace program to export a file system to the Linux kernel. So think about the word FUs. It means file system in USpace. So for us, we can think that we can implement a totally file system in USpace, not just switch to the kernel again. So this is a comparison between the SPDK Vhost-fs target and Virtio-fs. Actually, from the left part, from the guest and the queuing part, both SPDK and Virtio-fs are the same. From the right part, the top layer is SPDK Vhost-fs, and the lower area is the Virtiofsd. So from the two diagrams, we can see that the biggest difference between the Vhost-fs and the Virtiofsd is that Virtiofsd pass through the request sent from the VM to the local host file system again. It do the pass-through. And from SPDK part, all the IO logic is processed inside the SPA USpace process, and it will the IO request will be done inside the SPA process. And for this solution, actually, SPA does has some advantages and disadvantages compared with Virtio-fs. The first one, of course, is SPDK admits USpace to kernel context switch by providing a USpace file system. And there are also some difference between the IO thread model. Stephen just mentioned that for the Virtio-fs, the IO queue is per thread, but for SV part, we use one poller, means one thread to pull all the Virtqueues. And the disadvantage for Vhost-fs is that page cache in host can be shared for Virtio-fs, which is very important for the continuous usage scenarios, but it's not available for SB now. And of course, the biggest advantage for SB is that we can easily to add some new features in USpace, because let's take the MMSD as an example. MMSD will have some very good features such as round namespaces and the streams and also MME sets. So those features we can definitely use it in the file system. It will get us more easier to understand the workload from the guest. So this is one mapping table between the SPD Blobfs APIs and the Fuse APIs. By the way, all the SPD APIs are asynchronous. So that means all the requests processed, you must provide a callback. And you will get notified, get a notification when all the requests are done from the backend SPDK process. And this is the obfuscation mapping of the Fuse request in the Virtqueue. Actually, for this part, it's the same for both Virtio-fs and SPV host target, because this is the protocol definition and the implementation. And this is another example for the open and close APIs. The open API will have two Fuse requests. The first one is lookup, the other one is open. And accordingly, there are three SP APIs to address the open request sent from the guest. Similar for the close API, I will not go through it. This is an example for the implementation details with read command. Guest will send the POSIX read, and it will change to the Fuse read. and send it to the Virtqueue. And SP will pull this Virtqueue and process and send it to the backend Blobfs, and finally it will get back from the backend. So to address the questions raised in the previous slides, so with this SPDK Vhost-fs target, so we will have the RocksDB running in the VM, and it will see a file directory in the guest, and it will send the fuse read and write command, and we will change this command to SPDK Vhost target. This is the final process for the SPDK Vhost-fs. So the other part is for the container solution. So actually, at first we do not think we can run it with some container solutions. This is, but finally we changed it to the Virtio-fs. We found that it can also be used in the Kata container. So Virtio-fs in the Kata container storage, so it offers local file system semantics and performance. And Virtio-fs daemon will handle the VM request. And the Virtio-fs daemon performs the IO request with file system calls. So this is the common diagram for the Virtio-fsd. Look at the left part. There is an overlay FS driver in the host side. So this is very important for us because there is an overlay FS driver in the host side. And I will mention the issue for SPDK Vhost part because we cannot support this overlay FS in the host side. So the challenge for using SPDK Vhost-fs in the Kata containers, so there is the requirement the shared file system is required for the Kata container for the root FS image. And there is the overlay file system for container image. But the most important issue for SP is that no direct view from a host side when using SPDK Vhost-fs, because you cannot use the ls command to list the directories or files in the host side. You cannot see that directory. So for this issue, how to use SPDK Vhost-fs with Kata containers, we do have some requirement about the root FS usage, but we cannot support it for now. But so we are changing our mind to support the data volumes. So data volumes can be used for the shared data between different containers. So this is SPDK Vhost-fs in the Kata container storage. And the users can start the Virtiofsd to start the root FS image, and then start another process. Here it is SPDK Vhost-fs, and to provide the data volume. So for this issue, again, overlay FS and maybe some other drivers still can be used in the host side to provide the root FS image. And for the data volume part, because this data volume is persistent to the directory or the storage medium. So for this part, we do need a small patch in the Kata containers to start SPDK Vhost-fs and to mount the data volume into the VM. So go back to our previous issue. So we cannot use the ls command in the host side to list the directories and the files in the host side, but we do provide a Vhost daemon tool in SPDK. With that daemon, we can see the directory view from the host side to list all the files in the created by the VM for the data volume. So that means we can run in Vhost daemon, SB Vhost daemon, and SB Vhost-fs in a same in different process or in the same process with different threads is both okay. So this is the summary for the SPV host target. Sharing between containers can be supported. And the sharing between containers in different VMs can be supported too. And the sharing between containers in one VM, we can support this. And there is one issue for now, is how to sharing between containers in different hosts. For now, it is not supported. So so we'll go the final part. As I mentioned in the previous slides, at first, the Blobfs is designed for the RocksDB only. So that means we can only support the RocksDB. So look at the RocksDB's data streams. Actually, the streams I/O from the RocksDB is very easy because it can only send the write request with append write. So that means we cannot support the random write for now. But if we want to change the Blobfs to meet the common requirement, so we may need to add the random write support. And the other issue is for the cache part. We have a read-only cache in existing Blobfs, which can used to address the read-ahead from the RocksDB. But with this cache, we cannot enable the random write. So if we want to enable the random write, it means we will redesign this cache module, or we can remove this cache module. So actually, from this point of view, if we redesign the Blobfs, we may add more features in this library and to meet a more common requirement. So the other part is we can integrate with PMDK persistent memory development kit for the data management for the common file system. It means we can use the PMDK to store the persistence, to store the R node, and leave the data maintained in the SB blob store. So this is the work I'm developing, work in progress to design a new, maybe we will rename it to another name, PMFS, maybe. So that's a common requirement. And the other part is about the root FS image used with in the US-based file system, because root FS image is still very important for the container scenarios. So for this part, if we want to support this feature, we must add the snapshot support. So for this part, we have two choices for now. So we can enable in the block clear, or we can enable it in the file system layer. But for this part, we are doing some research for now. So this is the patch we submitted in our GitHub. You can take a look if you're interested with this patch. All the kernel drivers and the QEMU drivers is already there, so you do not need the actual patch to enable this with SPDK Vhost-fs target. So Q&A.
Hi. So I found the future items slide interesting, the idea of using PMDK to do stuff, because a lot of the existing file systems, they're not really designed for that, and things like fsync are very slow because you need to put all the metadata in place, and with PMDK you can do it very fast. And in Virtiofs's DAX, what we're doing is we're mapping host memory into the guest, so the guest has fast access. So I wonder, do you think that it might actually be possible to map the PMDK, to map the PMEM into the guest, and then access that directly? And now it's persistent. It's not just for cache. Do you think there are things that can be done there?
So you mean pass through a PMDK or part of persistent memory into the guest to store the files?
So instead of communicating with SPDK or anything on the host side, what about just mapping that memory, that PMEM memory, into the guest, and then you could you could basically go even further than Virtio-fs. You could bypass even more, basically. You see what I mean?
I get your idea. So you mean we can add some features in the Virtio-fs driver to enable this feature? I think for so for this part, we do have some other requirement. Maybe the guest client maybe is not Virtio-fs, so maybe we will provide a common library to some users. They can integrate the Blobfs library into their own application. It means it does not require the guest must be a Virtio-fs client. So for us, I think for the Virtio-fs, it may be a great idea, but for us, we'll still to think about to provide a more common libraries to address more requirements from customers.
Okay, there are no other questions. Thank you.
Thank you.